Hello and welcome back to Calculus 1. We are going to talk about fundamental theorem of calculus. So we learned enough calculus so far, so we can talk about the fundamental theorem. We started with limits, then we did derivatives, then we took the antiderivatives, which turned out to be integrals. And we've seen also the integral, right? The definite integral was defined also through the limit. So it all ties in together. And now we're going to take a look at the fundamental theorem, keeping in mind that integrals are antiderivatives. So fundamental theorem of calculus has two parts. Part 1 So hold on, why? So FTC, fundamental theorem of calculus, has two parts. Part 1 you already learned. Integral from a to b of f of x dx is any antiderivative f of x computed from a to b, which is f of b minus f of a. And that one returns a number. So that's our part 1. Part 2 is new. It says the derivative of the integral from a to x of f of t dt is equal to f of x. Can anyone tell me what is this, the part 2? We know the part 1, area under the curve. We talked about it, right? How about part 2? What does it look like? What do you think it states? Yes? What do you mean derivative?
The derivative of the antiderivative of the function is just the function.
Yes, 100% of what you said is true. What does that mean in the most plain language that you can put together? It doesn't even have to use math terms. In plain language, what does it mean? Yes, that's it. You know how addition and subtraction are opposite of each other, and multiplication and division, and right? Well, integration and differentiation, they're opposites of each other. So derivatives undo integrals, right? And you can see that over here you have a function in terms of t, you have the same lowercase f function just in terms of x. So technically, as if these two canceled, and you just got whatever you put in, you got in the other end. It's just in different variable. The proof for this is very simple. The derivative of integral ax of f of t dt will be the derivative of, in terms of x, the antiderivative of f of t is capital F of t, but you need to compute that from a to x. So the derivative is f of x minus f of a. Now the derivative of antiderivative goes back in the original function in terms of f of x, and the derivative of f of a, well, a is a constant, a number, a 3, 7, whatever. When you plug that in a function, you get another constant, right? So minus 0, and you just get f of x. So let's do the example. This was a proof. So if you have the derivative of the integral, let's say 3 to x of sine t dt, you just get to write sine x. That's that. Now, if you want the proof for it, you can actually do the proof. D dx, where integral of sine is negative cosine t, computed from 3 to x. This is derivative of negative cosine of x minus negative cosine of 3. And now the derivative of negative cosine is negative sine, because the derivative of cosine is negative sine. And I'll just put minus 0 because I don't care about the second part. Or actually I can put plus 0 because minus and minus make a plus. Cosine of 3 is a number. And if cosine of 3 is a number, the derivative of that is 0. So all I get is sine x. So you see that I started with sine t, and I just ended up at sine x. So all this statement for fundamental theorem of calculus, all is it saying is that derivatives and integrals are opposites of each other. You know that if you differentiate x squared, you get 2x. If you integrate 2x, you get x squared, right? Sure, there's the plus c and all of those subtleties that we talked about, but fundamentally they are different. And now, to close out this lecture, I'm going to write those definitions that you know from 3 months ago, right, 2 months ago, and the one that you've seen today, side by side. F prime of x is limit h goes to 0, or f of x plus h minus f of x divided by h. The definite integral a to b of f of x dx is given by limit n goes to infinity, summation I goes from 0 to n of f of xi delta x. Can you look at these formulas and tell me why and how are derivatives and integrals opposites of each other? Come on. Just state the obvious and class is over. you are looking at the two formulas, one for derivatives, one for integrals, and I am asking you to tell me exactly how are they opposite, why are they opposite. Okay. H goes to 0 and goes to infinity. Sure, that's completely opposite. Anything else? If anyone needs lenses or something, let me know. It's right there. Just say it. Yes. Yes! Look at that. Right? What else? Yes! This is called division, and this is called multiplication over here. You see that they're completely opposite of each other, right? One is using subtraction and division in a derivative, and h goes to 0. The other one, n goes to infinity, sum and multiplication, right? All of these operations undo each other, right? So that's that. So now you have all of these concepts put together, I hope. There are no calculations in this section. This is purely theoretical session that wraps up all of the calculus since chapter 2. We have limits, derivatives, and integrals in these two lines. All of the concepts that we were covering in the last 3 months. And now we see also in which way they are opposite of each other in operations they use and way they're put together. And the next section is going to be very short, 5.4. We're going to see few formulas that are going to sweeten and ease up on our calculations. And then 5.5, use sub. Make sure you do your class prep for those two sections for next class. And work on homework. I will see you all next week. And when I say all, I mean all. Also, final exam review is going to be there, and Calc 2 prep for about 15 minutes or so. Bye.